Okay, 6th grade, now that we know how to do proportions, we're going to put this in with scale drawings, page 417 in your book. Get my pen to work again. Okay, page 417. Okay, a scale drawing is, and this is on page, it goes back to page 72. Let's see what they say. I'm going to go back to 72 just so I can get the right words with it, alright? Page 72 in your book, it says, a scale drawing is the same shape as the original object, but not the same size. Okay, so same shape, different size. For example, if you were an architect and you were designing a building for somebody to get their approval to go build, you wouldn't build an exact version of it. You would build a scale model of it, which would be a smaller version that you could take in, or a person could come and they could see that you could set on a table. The scale is your how big, like you're going to make it 2 times the size. You're going to make it half the size. That's the scale. The scale is a number that you multiply by or divide by. Okay, so let's take a look. We have a scale drawing of a soapbox race car. These are cool. We used to do these at the church, have races with these all the time. In the scale drawing below, the car is 2.8 inches long. What is the actual length of the car? Okay, the scale, notice down here in this corner of the picture, that's the scale. 1 inch equals 2.5 feet. So every one of the, every inch equals 2.5 feet. So the length is 2.8. So in the picture, okay, well, they wrote the same fraction down here. You can write the given information right here as a ratio. All right, so there's a ratio for that. To find the actual length of the car, write and solve a proportion. Let x represent the car's actual length in feet. Okay, so you have our scale which is 1 inch. I can get my pen back, I find it. 1 inch equals 2.5 feet. The scale model, if you look back, the length of it is 2.8 inches. So how many feet would that be equal to? So again, this one is a little tougher. Well, it's not quite as bad. We could probably solve this one by just multiplying, but they have us, 1 times cross products right here. 1 times x is 1x. 2.5 times 2.8. 20, placeholder 10, carry the 1, 5. Put in 2 places, so it's going to be 10. It's not 10. 2.0, carry the 4. 16, 20. Placeholder 0, carry the 1, 5. 0, 0. Where am I getting 10? I multiplied. That's 7. So 1 times what is 7? 7. So the actual car is 7 feet. Oh, that was derby cars we did. We didn't do soapbox. Soapboxes you can actually sit in. These are like, you can really race those and get in them and go down a hill. I thought I was thinking of, what we used to do at church was the derby cars, because I was like, wow, our derby cars weren't 7 feet long. So there's our proportion, the cross products, and the answer was 7. Use the scale drawing above to find the width of the car. So for that one, we have the same scale. 1 inch equals 2.5 feet. Now the width is how many inches. In the picture, it's 0.6. So now they want to know what is the actual width then. So again, we do our cross products. We get 1 times x equals 2.5 times 0.6. And I put in a decimal. 2 decimal places actually. So it'll be 1.5 feet, which makes sense. The width needs to be smaller than the length. The actual distance from the front axle to the rear axle is 5.5 feet. Find this distance in the scale drawing above. So the scale is, again, the same scale, 1 inch equals 2.5 feet. This time they're telling us that it's 5.5 feet. They want to know what is it in the inches in the scale. So we'll do our cross products. 2.5 times x equals 5.5 times 1 right here is 5.5. 2.5 times what is 5.5? Well, I don't know that. So 5.5 divided by 2.5, over, and up. 25 goes in there twice, which is 50. Add another 0, bring it down, goes in there twice. It's 2.2 inches. So example number 2, a finished mural is to be 20 feet by 10 feet. Your scale drawing of the mural is shown. Okay, so 1 inch equals 10. This is an important down here at the bottom of the picture. This is our scale. Every inch equals 10 feet. So the picture is an inch because we can't draw that in our papers, and that 1 inch is 10 feet. 2 inches here would be 20. What is the perimeter of the drawing and of the mural? Okay, well, the drawing is 2 inches by 2 inches by 1 inch, 2, 4, 5, 6. The perimeter of the drawing is 6 inches. The perimeter of the mural is it's 20 and 20 and 10 and 10. 10, that would be 60 feet. Okay, find the ratio of the drawing's perimeter to the mural's perimeter. Okay, ratio means we write it as a fraction. The drawings one is first to the actual mural. Okay, so the drawing is 6 to 60, which divide by 6 is 1 to 10, and that's in inches, and that's in feet. How is this ratio related to the scale? Look, I just noticed it. It is the scale. Wow. See what they did. There's their perimeter. The ratio of the perimeter is equal to the scale ratio. 1 inch of perimeter in the drawing represents 10 feet of actual perimeter. Use the information from example 2. Find the ratio of the drawing's area to the mural's area. How is this related to the scale? Okay, so we go back to this picture. Let's do area this time. Area is length times width, so 2 times 1. The mural is 2. 2 times 10, the area of the actual is 200. So we'll go back 2 and 200. So we got 2 and 200. Okay. There's our 2 things. So 2 over 200, divide them by 2 would be 1 over 100. This time, since it's squared, you see these numbers, since they're squared, 1 times 1 and 10 times 10. Interesting. Okay, so let's do some guided practice. The scale drawing of another mural has a length, I'm just going to draw a picture, has the length 5 centimeters and a width 3 centimeters. The scale is 1 centimeter is equal to 2 meters. It's easier if they're not going to give me a picture to draw it out. They'll probably give me it on the next slide, but we'll just draw our own picture. What is the ratio of the perimeter of the drawing to the perimeter of the mural? Okay, so the drawing is 5 plus 5, 3 and 3. The drawing perimeter is equal to 16 centimeters. The actual, every centimeter is 2 meters, so this would be 6 meters, and this would be 10 meters. 10, 20, and 12, 32. So the ratio would be 16 to 32, which is 1 to 32. Actual is meters. Sorry, that's not centimeters, that's meters. So it'd be 1 to 2. That came out the same. What is the ratio of the area? The area of the scale would be 15 centimeters, 3 times 5. The area of the other is 60 meters. This is squared and this is squared. Divide them by 5. That's going to be 3 twelfths, which is 1/4. And again, remember they're squared. 1 times 1, and 4 is 2 times 2. So there's where the half comes in, is because we squared it. All right, so we'll give those a shot. Again, it's really all it is setting up proportions. If you run into a snag, just let me know, and I will be glad to help you with it. We will see you next time.